السلام.
عليكم السلام ورحمة الله وبركاته.
Yes, I will start the last chapter today, which is chapter 13. Chapter 13, let's see. Okay, this is chapter 13, of course. Are we going to take chapter 12?
No.
No.
Chapter 12 is not part of this course. Good. So we jump from chapter 11 to chapter 13, and the title of the chapter 13, Physical Properties of Solution. We talked in chapter 11 about what?
Solids and liquids.
Solids and liquids. And in chapter 10, gases. And in chapter 13, what are we going to talk about?
Solution.
Solution.
What's the solution? Okay. What's the meaning of solution?
A mixture.
Of what?
Solute and solvent.
Solute and solvent. It's solute and solvent to make the solution. All right? Good. So, when you put solute you're going to make solution by solute plus solvent to make solution. I'm going to define certain things. First, I'm going to define what's saturated solution. Saturated. What's the meaning of saturated?
مشبع.
Full. All right, مشبع, yes. مشبع or مشبع, I don't know. مشبع ولا مشبع?
مشبع.
Yeah, maybe مشبع is better word than مشبع. I don't know. All right, what do we mean by saturated solution? This means the solvent cannot take no more solute. This means if you have a solution like this, you will find some of the solute out, even though it should dissolve, but some of the solute is out. Why? Because the solvent cannot take anymore. This means, let's assume that there is 10 grams here down, 10 grams. If to the same solution I added 3 more grams, what will happen to the 3 more grams? They will come out, and I'm going to have plus the 3 gram extra. What do we mean by unsaturated? Unsaturated is when all the solute is dissolved. This means we say unsaturated.
Doctor, does this has to do with the concentration?
Of course, it has to do with concentration, definitely. What do you mean by, very good. What do you mean by, then what's saturated means what? The concentration is what?
High concentrated.
The maximum. Saturated means the maximum concentration. You cannot put any more. All right? So if it's below that, then it is unsaturated. In Arabic, غير مشبع. This means you can add to it. You can add more to it. All right? Is this clear? Okay. Now, if you have a solution, this is unsaturated. All right? If you add more solid, more solute, what will happen? It will dissolve. What's the difference between solution 1 and solution 2?
Second, more concentrated.
What?
The second one is more saturated.
Yes, more concentrated. Not more saturated, more concentrated. Very good. You add even more and still it dissolves. What will happen?
More concentrated.
Still unsaturated, but more concentrated. Good. When you reach 4, you see some of the solute out. What does that mean? Now this is what?
Saturated solution.
Saturated solution. Saturated solution. Clear? Let's assume this saturated solution is at 20 degrees, 20 or 25 degrees centigrade. Now, what will happen usually if you heat it to, let's say, very high, much higher temperature, 70 or 80 degrees? What will happen? It will dissolve like this. So, even though it was not dissolving at 20, but if you heat it to 80 degrees C, what happened? The solid went into solution. Is this clear? Why is that?
The water will evaporate.
No, not the water will evaporate. The water can take more at higher temperature. That's what we're saying. Okay? So the water can take more at higher temperature than at lower temperature.
Doctor?
Yes.
So at step 4, it's not saturated yet, right?
No, 4 is saturated.
But it could take more.
Yeah, that's what I'm saying. Saturated at 20 degrees. But you change the temperature. Now it becomes maybe unsaturated, but I have temperature. That's another temperature. You change the temperature. If you change the temperature, then everything changes. Clear?
Doctor?
Yes, clear.
Yes, clear.
Doctor, what happened from 2 to 3?
What? What temperature is 1 and 2 and 3 and 4? What's the temperature?
All the same.
What happened from within 1 to 2 to 3? You tell me.
1 to 2, we added more of the substance or the solute.
And what happened?
It got more concentrated.
Dissolved.
It dissolved, yes.
In 3, what happened?
I am not sure.
It dissolved. That's it. I'm saying it's from 2 to 3 exactly like from 1 to 2. 1 to 3 is exactly the same.
Okay.
But again, 3 is more concentrated at 20 degrees centigrade. When you reach to 4, what happened? You reach saturated. Saturated at what temperature?
20.
Degrees centigrade. This means that the solution or the water cannot take any more. Some will come out like this. This is saturated. Now I change the temperature. I heat it to 80 degrees centigrade. What happened? The thing which was not dissolving, it dissolved actually. Clear?
Clear.
Good. Now we're going to take 5. Still we are in solution 5 now. And we're going to cool it down slowly. Now until it reaches 20 degrees C. And we see that everything is dissolving. So we cool it from 80 to 20, that's 5 again. And so I'm going from 5, this is 5, I rewrite it here, to 6. What did I do? I cool it very, very slowly. At 20 degrees C, still there is no precipitation. This means in 6, the solution is taking more than what it needs. This solution, we call it supersaturated. What we call it?
Supersaturated.
Supersaturated. Supersaturated. How can I tell that it is super? But you have to do it very, very slowly. And don't shake. No shaking of the beaker. Don't shake the beaker. No shaking, and do it very slowly. Now, how can you tell it is supersaturated? If you take 6 and add this amount, I added this amount of the solute, I added to here. Only this amount. See, it's very, very small amount. I will find that this amount comes. If you add anything to it, very small amount of the solute, add very small amount of solute, a lot will come. And now the solution become again what? This is at 20 degrees still. 20 degrees C, it become now saturated. Is this clear? So what's the meaning of supersaturated? Yes?
It accepted more than it could handle by heating it and then cooling it slowly.
Saturated or supersaturated contains more dissolved solute than it present in saturated solution. It is taking more than saturated solution, but it can handle it. This means a lot more than more solute than in concentrated solution. Is this clear? Good, I hope so.
Clear.
Now, next, this table shows how can we make, this is the solute and the solvent. We can make it from gas into gas. Give me example of solute and solvent, gas and gas.
Air.
Example is the air around this.
Air.
We can have gas and liquid. Give me example of gas and liquid.
Carbonated water.
carbonated water, which is actually Pepsi and Coca-Cola and all of these things. They put gas in it, which is CO2. They put CO2 in this bottle and you enjoy drinking CO2. Imagine if you keep the bottle open and you expose it to sun, what will happen? All the gas will come out and you'll find that you have only water and sugar. Okay? Gas and solid, not important. Liquid, in liquid, we can have many of these things. Example, ethanol in water. Liquid and solid, we can also have this. Liquid and solid, not important. Mercury, silver. Solid and liquid, yes, of course. Solid and liquid, you're very familiar with this. What's this? Salt
water.
Salt water, exactly. And solid, if you have brass. But the important ones is actually 1 is very important, 2 is important, and solid and liquid are important. The rest are not important. Okay? These are examples of how solutions are made of. Good. Why things dissolve? Why things dissolve? Okay. Why water dissolve? I mean, in NaCl, why does it dissolve in water? Because it's all related to forces. If you have an NaCl, what type of bond is between them?
Ionic.
Ionic bond. And it's a strong bond. How come the water can break this bond and dissolve an NaCl? When you dissolve an NaCl in water, what will happen? You're going to have Na plus and Cl minus. What did you do? You broke the bond between Na plus and Cl minus, right? How can you break it? Why you can break it? Because what will happen actually, each Na, if this is Na plus, there is water is, we know that water is what? Polar compound, right? Is partial what? Negative, and this side partial positive. So when you dissolve Na in water, you'll find that there will be oxygen around it, like this. Okay. And Cl minus, you'll find that hydrogen around it, or water from hydrogen making the bond. Now, why does NaCl dissolve in water? Because these bonds, even though these are weak bonds, and these bonds must be greater than what? The ionic bond. Clear? Okay, let me ask you a very simple question. If you put calcium carbonate in water, it does not dissolve. Tell me why.
It contains carbonate.
Yeah, but from what I just explained now, why calcium carbonate does not dissolve in water?
Because the force between the calcium and CO3 bigger than the
Exactly. The ionic bond here.
dissolved.
The ionic bond is what?
stronger.
Stronger.
Than the total Ca with water and carbonate with hydrogen. So you know now why ionic compounds dissolve?
Doctor, could you repeat it, please?
I repeat one more time. NaCl dissolve in water. If you put NaCl in water, you're going to have Na plus and Cl minus. You are going to break the ionic bond, so you break ionic bond. Right? And then you're going to make what? Ion, what's the name of this bond? Ion what?
Dipole.
Ion dipole interaction. Okay. Why does NaCl dissolve in water? Because the ion dipole interaction is stronger than the ionic bond. Clear? While for calcium carbonate, the ionic, the ion dipole bonds are what? Weaker than the ionic bond. That's the only reason. Did you understand?
Yes.
Yes, thank you, Doctor.
Doctor,
Okay, yes.
how do I know if it is stronger or not?
From chapter 4, you have to go to chapter 4. Okay? But I'm giving you the reason now. Otherwise, we took this in chapter 4. We told you that all the alkali will dissolve, all this will not dissolve in chapter 4. And this is what we are doing here. But I'm now giving the reason. Clear? Now, as I said here, what do we call this bond?
Ion dipole.
Ion dipole.
Dipole. Okay. And this is this is also ion-induced dipole or dispersion. Induced dipole. Okay. Now, as I said, the ion dipole, in order to have the dissolving, should be greater than, of course, if we talk about NaCl, what type of bond between Na plus and Cl minus? Ionic. And this ionic is what? Strong bond. Right? While the ion dipole, is it strong or weak? Weak. Why NaCl dissolve in water then?
Because its ion dipole is weaker than ionic.
It should not dissolve. If it's weak, you're breaking strong bond and making weak bond. Because we are having many ion dipole. It's not one. There is water everywhere. Got it?
So it will be stronger.
The total will be stronger, yes. Each one is very weak, but the total should be stronger than this one. Clear?
Yeah.
Good, I hope so. Now, what are we doing when we make solution? We are breaking the bonds between the solute. As we said, if we talk about NaCl, what are we doing? We're breaking the bond between Na and Cl. We need heat. This heat is delta H1. Clear? So what's delta H1?
The heat needed for breaking the bond.
Breaking the bond, which is the reverse of the bond energy. Right? Good. And also, we need to break the bonds between the solvent, delta H2. What's delta H2? If you have water molecule, they are attached to each other. By what?
Hydrogen bonding.
Hydrogen bond. And now, when you want to make the solution, you need to break these bonds as well. That's delta H2. So we need to break the bonds of the solvent. And then what will happen? You're going to take the solute. And of course, delta H1, is it positive or negative?
Positive.
How about delta H2?
Positive also.
Why if delta H1 and delta H2 is positive?
Composition.
If you break bond, what does delta H?
Endothermic process.
And delta H is must be what? Greater than 0. Yes. Okay. So delta H1 and delta H2 must be positive and positive. Then you're going to take the solute and the solvent. This is the solute, which is broken solute and solvent, and you're going to make the bonds between the solvent and the solute. Delta H is the, now, for the case of NaCl, it will be Na with oxygen around it, and Cl with hydrogen around it. And is this going to be positive or negative? Is this endothermic or exothermic? It is exo. Why is it exo?
Formation.
Yes, always. If you break bond, this is positive. If you make bond, delta H is what?
Negative.
Is this clear? Okay, and that's why delta H3 is less than 0. Now, delta H solution is H1 plus H2 plus H3. And that's the net. Now, when you see this net, is this going to dissolve or not dissolving?
It's going to dissolve.
Well, look
Maybe.
at our diagram very well, and you should answer me. Is this?
Maybe.
It should not dissolve, actually, from the heat point of view. Why? No,
Because delta H positive.
delta H is positive. Why delta H is positive? Because delta H1 plus delta H2 is what?
Greater than delta H3.
And this means you're going to pay more energy. So from the heat point of view, it should not dissolve. From delta H, it should not dissolve. Clear? Are you following me?
Kind of, doctor.
Huh?
I couldn't completely understand.
يعني الآن أنت الآن يعني you're paying more energy. You need delta H1 is positive, right? So you're paying energy. Delta H2 is positive. You're paying energy. Delta H3 is negative, and so you're gaining energy. So you are putting energy here, put energy, and you put energy here. Here you gain energy. But what's the total? Is it going to be positive or negative?
It's supposed to be positive
Why? Because
because
delta
one
and delta H2 is greater than delta H3, and that's why delta H, the delta H solution is positive. Clear?
yes.
If delta H solution is positive, the process should not happen. I say here delta H1 and delta H2 is greater than delta H3. This means it should not dissolve. It should not dissolve. Clear?
Yeah. So the main idea, doctor, is that first we're breaking bonds, right?
Right. The whole idea is breaking and making bonds.
So it's for step 1 and 2, they're the same. We're just breaking bonds. And what happened in step 3?
We're making bond.
Between the solvent and the solute.
Exactly.
Okay.
And that's why. But the total energy in step 3 is less than step 2 and step 1. And that's why you will end up paying energy, which is not favored. We don't want to pay energy. The whole process is endothermic. The whole process in this case, it is endothermic. And it should not dissolve. If it's endothermic, it should not dissolve. Is this clear?
Yeah, so it has to be exothermic for it to dissolve.
يعني I'll give you another example. Let's if we have delta H1 is like this. This is delta H1, which is breaking of bonds. And delta H2 is breaking of solute also. Delta H2 is like this. And delta H3 is like this. Now, in the thing I draw here, I'll say diagram 2. In diagram 2, they end up, the total point, is it exothermic or endothermic?
It's exo.
It's definitely exo. Why it is exo? Because delta H3 is always negative, delta H1 is positive, delta H2 is positive, but delta H3, as you can see from the arrow, is bigger than delta H1 plus delta H2. Is this clear?
Yes.
And it would be exothermic. Is the solute going to dissolve in delta H3?
Yes.
Definitely it will dissolve. Definitely dissolve. Is this clear?
Yes.
Yeah. So, doctor, in the first one, it's not going to dissolve.
Yes. Well, from the heat point of view, in first one, I'll call this process 1. In the process 1, it should not dissolve from heat point of view because the total is endothermic and it should not dissolve. while this one in 2, the total is exothermic, it will definitely dissolve. Is this clear?
Clear, Doctor.
Very good, I hope so. Now, we will find in process 2, even though it's endothermic and it should not dissolve, but we find that actually it dissolves. Why? Because there is another factor other than the heat. This is the heat factor. Endothermic is enthalpy or heat factor. But there is another factor called entropy. What's the word?
Entropy.
Entropy. Entropy. I want you to memorize the name very well. Entropy. What's the meaning of entropy?
فوضى.
Chaos.
Oh. What does it mean? Disorder. Disorder. أو فوضى, chaos, yes. That's the meaning of entropy. What do you mean by entropy? Like, for example, if you have these gases together, are they going to mix if there is a bond, a barrier between them?
Of course not.
But if you take the barrier, what will happen?
They'll mix.
They'll mix together like this. There is no heat here because nothing happened. They just moved and mixed together like this. Why did they mix like this?
We remove the
Due
barrier.
to entropy.
Because of entropy. Because of entropy. Is this clear? طيب ايش معنى entropy?
Disorder.
Disorder. You have to memorize the name entropy and you know that it's actually disorder. Okay. What's the reverse of entropy? How can you go back to this one? If you shake it, are you going to go back to let's say this is 1 and 2? From 1 to 2, we can go very easily. Can you go from 2 to 1?
No.
Yes, you can, but what by what?
Intelligence.
Intelligence. By intelligence. So what's the reverse of entropy?
Intelligence.
Intelligence, الذكاء. You have to be intelligent enough to take the balls, the yellow balls, and put them in one side, and the purple ball and put them in the other side. Is this clear? I hope so. Good. One more thing before we go further. I want also, so entropy is very important. You have to know and understand. So let's go back to our diagram here. We find that in process 2, definitely it will dissolve. Why?
Exothermic.
Because it's exothermic. And of course, there is more entropy in solution, right? Okay, in process 1, we find it will dissolve, even though it is endothermic. Why?
Because of entropy.
Because the entropy is more in solution than in solute or solvent. Is this clear? Do you have any question? Questions?
Yes, doctor. So in the first one, it worked because of entropy, even
Yes.
though from heat perspective, it shouldn't dissolve.
Exactly.
Okay, and how can we know if it's going to dissolve or not?
You have to try it.
I mean, if we get a question, in the quiz or something.
If I tell you that delta H, the total delta H is plus 50, and even though this will dissolve in water, how come?
Okay, then we say it's due to entropy.
Due to entropy, because delta H, I gave you a number and I gave it to you in positive. I told you delta H is, for the whole process, is plus 50. This means we are in process 1, in which delta H solution is less than delta H of solute and delta H of solvent, and this means it should not dissolve from the heat point of view. But I tell you, even though it will dissolve, why? You should tell me, because it's
Okay,
good.
fair.
There is another rule I want you to know about it, which is very important rule, which is called like, dissolve, like. Very important rule. Like, dissolve, like. What do I mean by that? If you put an ACl in water, it will dissolve. But if you put things like, let's see, oil in water, it will not dissolve. You know, if you put oil in water, what will happen?
It will
Not
be the
dissolve.
top.
The oil will be up and the water will be down, right? It will not dissolve in water. Why is that?
It's not polar, but water is polar.
Because oil is not polar.
Yes, because the water is polar, it can make bonds with the plus and the minus, and this is polar, so it will dissolve in ACl, and oil is non-polar and will not dissolve in water. But if you put like things like benzene, the benzene that we have in our car, which is C8H18, that's most of the gas in our cars is this compound, C8H18. If you put it in oil, what will happen?
In oil?
Could
Yes,
dissolve.
dissolve.
It will
It will be
dissolve.
dissolved.
But if you put it in water,
Not dissolve.
so it depends on the intermolecular force. Intermolecular force. Good. Let's solve this problem very quickly. Dr2. Now, if we have water, and we know that water is polar. Everybody knows this now. And C6H6 is carbon and hydrogen only. And it is non-polar. Non-polar. These are our solvent. Now, I mean, our solvent, yeah. We have two solvents. If we put Br2, Br, is it going to dissolve in water or in benzene?
In benzene.
Benzene.
Yes, why?
Because it's
Not
non-polar.
Non-polar.
Polar. And I guess it will dissolve in benzene. Good. How about sodium iodide?
It will dissolve in water
It will dissolve in water.
Why?
because it's polar.
No,
It's ionic.
it's ionic, not only polar, it's ionic. All right?
So,
Good.
Doctor, it's polar and ionic.
No, it's not polar, it's ionic only. But
Okay.
because water is polar, there is a plus and negative in it. There is negative and plus here, partial positive, partial negative, it will dissolve it. Yes. How about CCl4?
Benzene. It's non-polar.
It is AB4 E0 from chapter 3. Is this polar or non-polar?
Non-polar.
Non-polar. If it's non-polar, is it going to dissolve in water or in benzene?
Benzene.
Benzene. All right. How about COH? Is it going to dissolve in water?
Yes.
Why?
It's polar
Where is the polarity?
to the oxygen.
It's like this, and it's polar like this, and it will dissolve in water. Clear? What's the
Yes.
rule? What's the rule?
Like dissolves like.
Like, dissolve, like. I hope it's clear. Good. Done with the entropy with this thing. Okay. Now, we're going to define a certain concentration unit. And I want you to write all these concentration units and be able to define. What's this letter? We took it before.
Molarity.
Molarity. What's a molarity?
Moles over volume.
Moles of what?
Solute.
Solute
Volume of the solution.
over volume of solution. Good. What's this?
Molality.
Molality. This is molarity. This is molality. And be careful here. What's the molality? Moles
Of solute.
of solute.
Over
What?
mass of solution.
What?
Over the
Over
mass.
1 kilogram of solvent.
The number of kilograms of solvent. Not solution, solvent. Be careful now. Clear? Okay. Now, also we have what's called mass percent. Mass percent. If I say percent of solute, mass percent of solute, what does this equal to? Mass of solute divided by what?
Total mass.
Total mass. And then we say percent. What does that mean?
Multiply by 100.
Exactly. How about if I say percent solvent?
Mass of solvent over total mass.
Mass of what?
Solvent.
Solvent divided by
Total mass.
total mass times
100.
Very good. Last one I want you to know very well is mole fraction. Mole fraction. And we give to it X. We took this before. What's the mole fraction?
Number of moles over total mass.
Or partial over total.
Ni divided by in total.
I'm not going to say now solvent, or I will call them the solute or the solvent. I will call it A and B. Okay, so I'll call solute A and solvent B. Okay, now If I say mole fraction of A, what should I say? It's moles of what?
A.
A divided by what?
Moles of A plus moles of B.
Yes. We have to put each one by itself because we cannot calculate the moles of A, B together. So mole of A, moles A plus what?
Moles B.
Moles of B.
B. And should I multiply by 100 I think?
No.
No. No. Now, what's the value for mole fraction?
1.
No, it can never be 1. Unless there is no A. It should be what?
It's less than 1.
Always less than. Okay. What's the mole fraction of B?
1 minus mole fraction of A.
Yes, it's our first moles of B divided by what? Moles.
Moles of A plus moles of B.
Moles B. Okay. And yes, somebody said, which is very good, if we have, mole fraction of B is always equal to what? 1 minus mole fraction of A, or mole fraction of A plus mole fraction of B equal to what?
1.
Exactly. You have to know this. And don't forget the name mole fraction, mole fraction. Is this clear? Good. A solution is made of 170 gram glucose in enough water to make 1 liter solution. Okay. The density of the solution is 1.062 gram. Express the concentration in molality. First, let's have this. And I want to calculate the molarity. Can you calculate the molarity? By the way, calculate the molarity. What are you going to do? The molar mass of glucose, this is the molar mass of glucose is equal to what? 180.2. Calculate the molarity. What are you going to do?
Bring them out.
What?
Bring them out.
Change the glucose into moles, then divide by 1 liter.
Okay. Okay. All right. Go ahead. Tell me how are you going to do it?
Doctor, isn't the water is the solvent?
The water is the solvent, yes.
We get number of moles. Mass over molar mass.
Go ahead, tell me how many moles. Calculate it, do it in your calculator.
Zero 0.944.
Exactly. Moles divided by what?
1 liter.
It says here to make a liter, this means 1 liter. 1 liter. And so what's the molarity?
0.94.
944. Exactly. Okay. Can you calculate molality? So this is right. Molarity is correct. Now we want to calculate molarity. What are you going to do?
0.944 over 1 kilogram of
Yeah.
water.
Do you have 1 kilogram of water here?
No.
How many grams of water you have?
Oh, wait.
Use the density and the volume.
Use the density to determine the mass of solution.
Okay, what's the mass of solution?
Density times volume.
Which is what? 1,000
1062.
Exactly, that's the mass solution. Okay, find molality. Did you find molality? What should we do next?
Find the mass of
Subtract the mass of solution with the mass of glucose to get the mass of solvents.
Give me a number.
$891.9.
891.9. Exactly. This is gram. Now calculate molality. What is it equal to?
Doctor, shouldn't we convert it into kilogram?
Sure. What's molality equal to? I'm going to say it's 0.944 mole. From where did I bring this number? Same number of mole, right? Divided by what? Come on.
By 8, 9.
Kilogram of solvent.
This is what? Give me number.
919.
0.8919. Exactly. Give me the answer.
Will be
1.05.
1.06 molar. Clear?
Doctor, why we subtract 171.1?
To have the mass of solute only. Molality, I want the solvent, I mean, the mass of solvent. Not like this one, this is solution, but this one is solvent. Clear?
Yes, clear.
Now, if I want to have the mass percent, can you do it very quickly?
Of what?
Of sugar, of glucose. What is equal to? Mass percent. 170.1.
1 over
1062.
What?
1062.
Exactly. Times
100.
Will be 16.017.
Okay. Can I find also the can we find the glucose percentage of glucose? I mean mole fraction.
yes.
How? We know the number of moles of solute, but we don't know what's the moles of water. How can I find moles of H2O?
Divide 891.9 by the molar mass of water.
Which is what? Give me a number quickly.
49.49.
So what's the mole fraction of glucose? By what?
0.944 plus 49.45.
And I hope all these answers are correct. Can you do it for anything?
Yes.
I hope so.
What's
Good.
part C, doctor?
نعم.
Part C, the question part C.
What's part C?
Parts per million.
Yeah. Oh, I did not talk about it. Okay. Yes, I'll talk about it right now. Oh, he said here, ppm, parts per million. Oh, yes. Sorry, I did not talk about it. But yes, What's the mass percent? I'll talk about it right now. What's the mass percent?
Six, I think.
Mass solute divided by what?
Mass of solution.
Total mass times what?
100.
Okay, the ppm, this very important word, ppm, what is it? Mass of solute divided by total mass, which is the same like this one, but this one times what?
Million.
100.
10 to the power 6, and that's why it's part per million. We also have, I'll take this away, I hope we already did this and we know it. We have also have ppb. ppb. Tell me what are you going to do? What's ppb equal to?
Mass of solute of total mass.
Mass solute over what?
Total mass.
Total mass times
Power 9.
9, exactly. That's part per billion. Okay, now we already calculated per mass percent, which is this one. What's ppm for the glucose in this case?
Uh, 169.45.
Or what you need to do now, if I want to put here ppm instead of, what should I do? Same thing, but I'll make this 10 to the power 6. In mass percent, it's 10 to the power 2. So I'll change the 10 to the power 2 and make it 10 to the power 6. And that's ppm. Is this clear?
Clear.
Yes.
Good. Okay, now, last question here, and rubbing alcohol is a mixture of isopropyl alcohol and water, 70% isopropyl alcohol by mass. So it is 70% by mass. How can you find the molarity? Okay, I will assume that if I have 100 gram total, then what's the mass of rubbing alcohol?
70 grams.
Rubbing alcohol. تعرفون ايش معنى الرابنج الكحول؟ شو هو الرابنج الكحول؟ هو اللي يمسحونه على يدك على اساس يعطونك لما تاخذ تطعيم الكورونا، الله يشفينا وياكم من الكورونا. قبل ما يعطونك التطعيم ايش يسوون لك؟ يمسحون المسحه، يسمونها المسحه الطبيه. المسحه الطبيه هي رابنج الكحول. All right, and what will be the rest? 30 grams is what?
Water.
Water. Okay. Now, can you find what is the molarity of the solution? Can you find the molarity?
Yes.
Yes, go ahead. Don't forget the mass And the molar mass, the molar mass of isopropyl alcohol is 60.09. So I have 70. This means how many moles do I have? Yeah. Come on. How many moles?
1.165.
Mole. Divide by, what's the total mass is 100 gram. What's the volume? Come on.
Doctor, it's mass over density.
Exactly, mass over density. 100 over.
It will be 126.58.
21?
That is 126.
126.58.
That's in milliliter.
Yes, milliliter. So what should I write down here? And give me the answer quickly.
Uh, 9.20 times 10 to the power minus 5.
No, it's only 9.2.
Yes, sir. Yes, 9.2.
1.2. Good. Can you calculate the molality?
Yes, the same number of moles.
5 mole. Divide by what?
We convert 30 to kilogram.
Exactly. Now I care only about water, so I'll use only 0.030 kilogram H2O. And what will be the molality? Give me a number.
38.83.
So we can calculate. So if we know the mass percent, we can calculate the molarity, we can calculate the molality. Is this clear?
Clear.
Of
Yes.
temperature, what's the effect of temperature in solution? Temperature, see, as you increase the temperature, this is when you dissolve gas or when you dissolve things in solute in solvent. If you increase the temperature, what will happen? There are some material like glucose, as you increase the temperature, what happened to the amount that you can dissolve?
It will increase.
Increase. Look at this one. It will increase. This one increase. This one increase. This one increase. This one increase. This one.
Stable.
No effect for NaCl. Okay. How about this one? Last one.
Decrease.
Decrease. Decrease. Is this clear? So what's the effect of temperature on solubility?
Often it's increase.
But there are cases in which what? We have
No effect or decrease.
exactly. That's all what I wanted to know about this. How about the pressure? The pressure is very important. If you increase the pressure, this means you increase the amount there, what will happen to the concentration?
Increase.
Increase P, what will happen? Increase solubility. Not solubility.
دائبية.
The maximum
دائبية.
amount of
الذائبية. الذائبية, yes. Solubility. And if you increase the pressure, what will happen to solubility?
Increase.
Increase. A law, I want you to memorize the name and the law, which is called Henry's law. What's Henry's law? Henry's law, very simple, very, very simple. It's C equal to K times P. What's C?
Concentration.
Concentration in what?
Mole per
Molarity.
liter or molar. Molar.
In molarity. And what's
Yeah.
P?
Pressure.
Pressure.
Partial pressure.
Of the gas. Partial pressure of the gas. And what's K?
Henry constant.
Henry's constant. Henry's law constant. Henry's law constant. That's it. Nothing can be simpler. C equal to K times P. Let's go to solve this problem. Now, calculate the concentration of carbon dioxide in soft drink. When you want to drink soft carbon dioxide, they put CO2. They put it under pressure. The pressure of CO2 is 5 atmosphere. Okay, so what will be C if at this concentration, if the pressure of CO2 is 5 atmosphere and the pressure constant is given to you here as this one. This is K. Okay, so what will be the concentration equal to what?
KP.
3.1 times 10 to the power minus 2, okay, times what?
5.
And that, don't forget the letter, the unit mole divided by liter times atmosphere. Now, we multiply by what? 5.0 atmosphere. Atmosphere will go with atmosphere. What will be left?
In mole per liter.
And that's why, what's the answer here? Give me the final answer.
0.155.
0.155. And what's the unit?
Molarity.
Molar.
Now, when you open it to the, when you open it in the air outside, when you open the bottle, what's the pressure of CO2?
1.
Less than 4.
No.
180.
1 atmosphere is the pressure of air. But there is very, very little amount of CO2 in the air. This is the total pressure of oxygen, nitrogen. This is the total pressure. But pressure of CO2 is actually only 0.0003 atmosphere. Because we want the pressure of CO2, the partial pressure of CO2 only. Okay, so what will be the concentration when you open it?
This number are constant, doctor, right?
No, it depends on the pressure of the air. But approximately, usually the air around 1 atmosphere. If the air is 1 atmosphere, then the pressure of CO2 only will be 0.0003. And what will be the concentration? 3.1 times 10 to the power minus 2 mole over liter atmosphere times what? 0.0003 atmosphere. Atmosphere will go to atmosphere. And what's the answer? Give me answer.
9.3.
9.3 times 10 to the power
minus 6.
minus 6. Exactly. Okay, with this, I will stop here. And
Doctor?
Yes.
The pressure for the CO2 is constant.
No, the pressure in the when they make it in the factory, they put 5 atmosphere. That's constant. In the air, usually, what's the atmosphere? What's the pressure around us in the air? تقريبا 1. اوكي، اذا كان البريشر 1 فالبريشر حق CO2 will be 0.003.
اوكي.
فما هو كونستنت اذا تقريبا كونستنت. ليش؟ لانه دائما البريشر حولنا around 1 atmosphere.
Doctor, it will be given, right?
Yes.
The pressure of CO2.
Of course.
Okay.
Okay. Now let's go to attendance. Please take attendance, and you can leave after that. Please take attendance, and you can.
دكتور، الواجب فيه صور ما تطلع، كيف نحله؟
فيها مشكلة.
ايه. ما اقدر اعرف الاجوبة.
طيب احاول اليوم ارسل لكم بشكل PDF. اوكي.
طيب هو موجود الPDF، بس اقصد في البلاك بورد كدرجة، يعني ممكن احط صورة تطلع غلط.
اعمل PDF وحلوه بالطريقة هذه. بسويها اليوم، حتجدونها في الكونتنت تشابتر 11 هوم وورك. في الكونتنت، مش في الهوم وورك، روحوا شوفوا في الكونتنت ايضا.
طيب نحلها ونرسلها ايميل يعني؟
لا، روح انت حلها في العادي بالطريقه، انت تشوف السؤال كامل وحلها بالطريقه العاديه يعني، بس حلها
دكتور، الواجب يكون على نماذج، يعني الأسئلة تختلف في ترتيب الخيارات.
لحظه الحين بوريكم شو بسوي من الان.